Hey, it's Dr. J. I'm going to finish 6.5 today, one way or another. So we're doing applications of proportion, part 2. I want to take a second look at the law of proportion and sort of give you another way of thinking about it. Let me remind you of the law. And I'll just spare you the verbal version of it right now. I'll probably come back to that in a minute, but and just write out the algebraic one. We say that A is to B, or A over B, as C is to D, if A times D is equal to B times C. Yeah. And that's the cross multiplying that we mentioned. You can put multiplication dots here to make it totally clear that you're multiplying, and you can draw the cross product here to emphasize that so you remember A, D, and B, C. And so this law of proportion can be used to determine if a proportion is true. Or if two ratios are actually proportional. In other words, if this is true, if this is true, then that means that these ratios are in fact proportional. In all of the examples I did in part 1, I kind of set them all up so that they were always proportional. But in life and in mathematics education and in application problems in general, you might encounter proportions that may or may not be true. And you might have to determine, is it in fact proportional? And so we can use this law as sort of like a regulator, or a sort of a math cop to, if this is satisfied, then you could say, yes, you pass, right? You are in fact proportional. And if not, then no, you're not proportional, or at least the proposition is just simply not true. So let me show you how that works. If I give you a proportion, or a presumed proportion, how you can use this law to validate or invalidate whether or not something is actually proportional. So let me give you an example. Determine if the following are proportional. Or not, yeah. So I'm going to have to erase this, but it's, same formula we were using yesterday. And I'll just give you a couple. I'm not going to go too much into this. I just want to kind of put this to rest, hopefully. So I'm going to say 8 is to 3 as 16 is to 6. And let me go ahead and put another one. 9 is to 4 as 12 is to 7. Now, if you've got really good, intuition or a good, understanding of the relationship between numbers, you might be able to spot which one is proportional and which one's not. They could both be proportional. They could both not be proportional, or, you have all the different possibilities. So the way you would set it up, A is to B as C is to D, right? And so you would say 8 over 3 is equal to 16 over 6 if 6 times 8 is equal to 3 times 16. So if this is true, then this proportion is in fact a true proportion, or you could say that these are proportional ratios. Yeah. So is this true? 6 times 8 is 48, 3 times 16 is 48, and so check, yes, proportional. So this is a yes. Yeah, it's true. So here's another one. 9 is to 4 as 12 is to 7. Yeah. Which on first sight you might think, oh, that makes sense, right? 9 and 4, look at the difference. The difference is 5. 12 and 7, the difference is still 5. So it might seem reasonable, you know, if you read this in a word problem or something, you might think, oh yeah, that makes sense, and I'll just set it up just like I set up every other problem. But this law enables us to really verify whether or not what you're seeing is the truth or not. So this is true if 7 times 9 is equal to 4 times 12. And then you can see that it's not true. 7 times 9 is 63. 4 times 12 is 48. These are not equal, so these are not proportional. So not every statement about proportion is in fact true. And so the law of proportion enables us to determine whether or not a proportion is in fact true or not. So you would say part B, no, not proportional, or you could say disproportional. And part A, yes, it's proportional. Now, what we're going to be doing today is taking a different look at how proportions actually work. Because I want to make something very clear in this lesson. It's probably my last chance to do this. This number 48 here, it really means nothing other than it's a verification that it is in fact true. But the number 48 really has very little significance in the process. Yeah? Because, you know, I could give you another true proportion, right? You know, I could say something like, and again, I'm not going to call this a new example, but I could say 8 is to 3 as, I don't know, 24 is to 9. Right? I'm just kind of modifying part A with another true proportion. Right? So you get 8/3 is equal to 24/9. And when you want to check whether it's true, this time you're going to get 8 times 9 and 3 times 24. This time the check value is 72. Right? So it's still true. Yeah. But it's not the same value. It was 48 last time, and now it's 72, right? And so this value really, it has very little to do with the actual value of the proportion. So when we're looking at proportions, maybe we should take a second look at what these ratios actually mean, right? There are infinitely many proportions that are all true. Right? A whole bunch of them, and they will all have different check values over here that are going to vary as you go through the different proportions. So, I mean, let's look at a simple example here. Let's take something like 3/5. All right. 3/5 is proportional to 6/10. Right? And I'm not even going to do all the math. Let's just do it mentally. 3 times 10 is 30, and 6 times 5 is also 30. Yeah, so those are proportional. But 6/10 is also proportional to 9/15. Right? So these two are proportional. Yeah. 6 times 15 is 90, and 10 times 9 is also 90. So notice that the check value, when you're doing the cross multiplication, is not the same value every time. But as long as the two sides are equal, doesn't matter what that number is, then that verifies that they're in fact proportional. And there's an infinite list of proportions. I could just sit here all day. If you give me $1 for every proportion that I could come up with, you know, I could generate an infinite number of dollars, you know. So look at this next proportion. 9 times 20. It's 180, and you might not memorize this one, but 15 times 12, that's one of those weird ones. 15 times 12 is also 180, okay? And so on and so forth. This list of proportions goes on and on and on and on forever and ever and ever. There is no end. ... I could just continue making this list of true proportions. And every time you took a pair of them and you tried to cross multiply them, they would all be true. Yeah. Now, you could even take ones from far away. Yeah, you could take these two guys. Yeah. 35, you could just ignore all the ones in the middle and just sort of take two of these. 35 times 3, what's that, 105? Yeah. And then 5 times 21, that's still 105. So as you go along the varying proportions, they're all true. Yeah, because these are all proportional ratios. So let's take another look at it. What does this actually mean if you think about it? 3/5, if you actually divide it, is 0.6. And if you don't believe me, that's one you should probably know by heart, but 3 divided by 5 is the same as 0.6, 6/10. Yeah. But look, this is also 6/10. And this is also 6/10. You might not recognize that one, but if you divide it, 9 divided by 15, it's also 6/10. Yeah. 12 divided by 20 is also 6/10. Right? And so if one of these is a mistake, like a disproportional ratio, then it would not come out to be 6/10. So suppose you made a mistake, suppose one of them was 24 or something, you just wrote it down incorrectly. Right? To spot that this is disproportional, you would just divide it, 15 divided by 24, and this time it's not exactly 0.6. So that means this ratio fell out of proportion. Yeah. Let's put it back in proportion. I want it to be true, so that's actually 25. And now look, 15 divided by 25, and there you go, it's proportional, 0.6. So all of these ratios all have the same proportion. They're all essentially 60% or 6/10. So what am I getting at here, Dr. Jordan? What's going on here? Well, look, these values can vary. Let's call it Y. Instead of A and B, I'm going to start using the more traditional algebraic variables like X and Y. So we're going to call the top Y, and Y could be any variable. Y, well, in this case, it's 3, 6, 9, 12, 18, but obviously I'm going to extend this to other versions of this. So Y is the numerator. It varies. Okay. X is the denominator. Yeah. X also varies. Where should I put that? Let's put that right here. X varies. Yeah. So these are all X's in the denominator. Just to keep it clear, I'll just put the letters over here. X in the bottom and Y in the top. So Y is changing, variable. Yeah. X is changing, it's variable. However, this does not vary. Yeah. It does not change. It's called constant. So, a real proportion or a true proportion is a ratio that remains constant. And this is a much simpler way, or maybe a more intuitive way of thinking about what does a proportion actually mean. So that means if you change X and Y, right, 3 to 5 or 9 to 15 or 15 to 25, so that's X and Y changing, but the output, the constant stays the same. And the symbol we use for constant, you would think we would use C, but we actually use K for constant. That's because we'll be using C for something else, like cost or coefficient or something like that. So we like to use the letter K for constant. Okay. Turns out that the German word for constant in German is constant, just spelled with the letter K. So you're all learning one word of German today if you don't already know. Okay. So where does that leave us? That leaves us at another version of proportion. I'll call it the law. So this is your second look at the law of proportion. Now, you might already be happy with the part 1 version of it where I did the cross multiplying and I solved for the missing value or the unknown value. But I'm going to show you another way to use this law of proportion to solve the same types of problems that we were solving yesterday. So example 2. Suppose, maybe it'll come back to me while I'm writing it. Suppose that 3 out of 5 people prefer chicken Chicken? Want to make it chicken? Okay. I don't know. I'm not going to give another thing. 3 out of 5 people prefer chicken over steak. I don't know if that's true, actually. I don't know. I'm trying to eat more chicken, but I prefer steak probably. So 3 out of 5 people prefer chicken over steak. Okay. If 750 people prefer chicken, and by the way, I should say people surveyed, because it's like you asked them a question. How many people were surveyed? So, what do we have? Okay, we have 3 out of 5 people prefer chicken over steak, right? So, chicken over steak. So, 3 is the chicken, 5 is the total, yeah? Spelled chicken right? Yeah. Now, it does not mean that 5 people preferred steak. It actually means that 2 people preferred steak. But I'm not asking about steak. I'm asking about how many people prefer chicken. So 3 out of 5 people prefer chicken over steak. So that means when we set up our proportion, 3 out of 5, yeah, is constant 60%, right? I already did that. 3/5 is 60%, or 6/10. Okay. And so that means that I can change the variables of x and y so we want to write them as variables, y over x, but I don't change the 0.6. The 0.6 is going to remain constant. So once I've determined this constant in this ratio or in this proportion is 6 out of 10 or 60%, yeah, or 0.6. And now I just have to remember, in the last lecture I called this making your bed, I just have to remember which one represents chicken and which one represents steak. Okay, so it says 750 people prefer chicken. All right, so chicken is y, and the total is X. So how many people were surveyed? I'm just going to solve this for X. Yeah. Because I know what Y is. Y is 750 now. So changing it to a variable. So now Y is not 3 people. Y is now 750 people. And so now this equation becomes very simple. It says 750 over X is equal to 0.6. Yeah. So the Y now used to be 3. Once you set up the proportion, now it's 750. And now you don't have that equation with the A, B, C, D. It's simplifying the process, and it's just saying solve this equation for X. 750 over X is equal to 0.6. All right. You don't have to do a cross multiply. In fact, this is probably a more algebraic way of solving it. It's a little less elementary. This is the way you'll be solving these types of equations in your next class. I probably shouldn't tell you this, but there are some folks out there that loathe the cross multiplying process because it's a little bit misleading. It leads to some bad habits in the future. And so to really make sure that we nail down this process, it's much better to use the techniques that we learned when we were solving for X or possibly solving for Y in the previous section. So this only has one variable, X. I'm just going to multiply both sides by X. So now I have 750 is 0.6X. And now I divide both sides by 0.6. Right. This is equivalent to what we did in part 1 when we were cross multiplying. It's just a little bit more elegant way of doing it. If you can use the word elegant in mathematics, 750 divided by 0.6, and you get 1,250 people surveyed. So this is another way of solving the proportion problems that I talked about in part 1. I'll leave it to you to decide. I actually recommend knowing both methods, and then in some problems you might prefer this method, and in other problems you might prefer the other method. Okay. If the other method was working well for you, I would just take this as an expository, I can't let you go without showing you this. All right. Let's do one more example of how this works. Suppose that, let's go back to the tree problem. Suppose that the shadow of a tree is 80 feet, and the shadow of a 6-foot-tall person is 4 feet. How tall is the tree? Okay, how tall is the tree? Well, we have a proportion, yeah? The shadow is 6 feet tall. We'll call that Y. Actually, let's call that X. I changed my mind. I like to call the shadow X because the shadow is flat. So you have like 6-foot shadow Now I'm confused. The 6 foot is the height of the person. Man, I'm confusing myself. So that is why. I'll put that one on top. Yeah. So you have the person is 6 feet tall. The shadow is 4 feet. I just read it wrong. The shadow is 4 feet. I underlined the wrong thing here. So here's your shadow is 4 feet. Yeah. So y is 6 and x is 4. Okay. So that's your proportion. All right. And here's the sun coming down and traveling in parallel lines. All right. So over here you've got a tree. And you don't know what y is, right? Y is unknown for the height of the tree. Right? But you do know what x is. You know that x is 80 for the tree. So this is an 80-foot shadow. And since light travels in parallel lines, the light from this shadow, as long as you're doing this at the same time of day, these should match. Right? These are parallel lines. So you set up your proportion. Find the constant first. So what is the constant? 6 over 4 is equal to k. You can probably do 6/4 by your mind. 6 divided by 4 is 1.5. 1.5. If you have to, go 6 divided by 4, and you still get 1.5. I don't know if you can see that, 1.5. All right, so find the constant of proportion, and then you just come over here to the tree, and you say y over 80 is equal to k, which is 1.5. Yeah, so first you find what k is. That's called the constant of proportion. Last time it was 0.6. This time it's 1.5. It essentially means the shadow is 1.5. The tree is 1.5 times the shadow. And then now I'm just going to solve for y. So sometimes you'll be solving for y. Sometimes you'll be solving for x. Solving for y is actually a lot easier than solving for x. You solve for y just by multiplying, in this case, both sides by 80. And so now you get y is 1.5 times 80, which we all know is 120. And so that means the height of the tree is 120 feet. Okay, so that is a second look at proportion before I move on to the next set of problems in the homework. So now you have two different ways of looking at how you're going to solve a proportional problem. Now, there's a very special type of proportion. A unit proportion. If y over x is equal to 1, this is called a unit proportion. In other words, the constant is 1. So that's your k. If your k comes out to be 1, we call that a unit proportion. Okay. So an example of a unit proportion. One thing that you might want to keep handy is I printed out a handout here. I hope it'll be legible when I'm filming with my camera here. So this is a handout that I want you to download from Canvas. So for the rest of the problems, you might want to have this handy. I made an extra large version of it. Your version's not quite this big, but it has all the same information. And this is a list of unit proportions. So if 3 feet is equal to 36 inches, then what is the unit proportion? Three feet is equal to 36 inches. Now, in the last example, I got a little hung up on choosing X and Y. That was only because I was being very particular about which letter I wanted to be X and which letter I wanted to be Y. It turns out it doesn't matter. All right, X and Y can vary, and they can be chosen by you. All right, that's what I referred to in part one as you make your choice or you make your bed. Okay, so don't really get too hung up on it. Just pick one of them to be X and the other one to be Y. It doesn't really matter. But once you make your choice, then you have to stick with it, at least until that problem is done. So all of these problems sort of have two different choices. So what is the unit proportion? Now you got to be careful. It looks like 3 over 36, right? Because y is 3 and x is 36. And you might write this. Yeah. But this is not true without the units, which is the whole reason why I've given you this list of the different units so that you can not only understand them, maybe hopefully memorize them, maybe not all of them, but some of the important ones that you might be using in life and in your future education, not just in math, but in other subjects as well. Without the units, this proportion is not a unit proportion, all right? Because to be a unit proportion, this has to be true, right? Look at y divided by x must be equal to 1. But down here, 3 divided by 36, I know I don't even have to do this, but you can clearly see that if you go 3 divided by 36, you definitely do not get 1. However, 3 feet, I'm just going to put FT for feet, is in fact the same as 36 inches, IN for inches, and now this is a true unit proportion. Yeah, so now it's telling the truth. Okay. All of these unit proportions have two different versions. So I could say 3 feet is to 36 inches, or I could say 1 foot is equal to 12 inches. This is the simplified version, right? Because 3 goes into 36 12 times. So you get your very first unit conversion, which you probably learned in elementary school. 1 foot is 12 inches. So 1 foot is 12 inches. All right. It can also be written as 12 inches is 1 foot. All right. So these are both simplified. Yeah, and they both equal 1. So 12 inches over 1 foot, that's equal to 1. And 1 foot over 12 inches is also equal to 1. So you have two different versions of the same unit proportion. This is a little bit geometric, really. I mean, it goes, at least this particular presentation of it is, you know, if you drew a line, you don't really have a triangle here, but if you drew a line and you called this 1 foot, right? And then you divided it up into 12 inches. Each one of these are inches. Yeah, so you've got all these inch marks. So that is the proportion. Yeah, the proportion is one of these, this is a foot, is equal to 12 of these little inches, which I'm marking off as 12 inches. Okay. So for the remainder of this lecture, I'll be referring to the unit conversions. Now, what I've done for you is I've already done all of the unit ratios. So these are all unit ratios. I write them out as equations. You can just think of it as x and y. Yeah, x and y, x and y, x and y, x and y. Yeah, or y and x, y and x, y and x. You will have a choice in each one of these problems, but I will show you a way of making that choice correctly. So next, converting units. Oh, example 5? Example 5. Three yards is equal to blank feet. 3 yards is equal to blank feet. Now, a lot of these at the beginning, you're going to know it right away, right? I mean, if you've been around on Earth for a while and you memorize, basic measurements, you're going to know. But as they get deeper and deeper into it, there might be a few you don't know. So I'm just going to show you this in its most general form, assuming, as if you had never heard of yards or feet before. I know that you all have, but I have to teach it as if you haven't. Okay. So when you're converting units, you want to multiply by a unit proportion. Okay? So, now here's the deal. When you're choosing, the denominator must match with whatever your original value is. So always make the denominator which is x, the unit that you started with. So the original problem starts with yards. Now, I don't want the 3. I just want the actual unit itself, yards. So I'm going to put yards in the bottom and then put the one you want in the top, feet. Always put the goal as y in the numerator. Okay? So the denominator should be x and the numerator should be y. And so I come over here to my chart. Now this is probably one you already know, right? 1 yard is 3 feet, right? 1 yard is 3 feet. But I have it here in the list just in case. So 1 yard is the same as 3 feet. So that's a unit proportion. Now I have to put it in the right order. So the 3 goes on top and the 1 goes on the denominator. Most of the math in this conversion should be relatively easy. I probably won't even need the calculator. I have one suggestion, though. Just to make sure that you multiply correctly, just put an invisible 1 down here in all of the problems. And that'll make sure that when you multiply, you don't make some arithmetic error. So you're going to cross off the yards. Yeah, think of those as numbers. Yeah, yards cancels with yards. And then you're going to multiply 3 times 3, and you're going to get 9 feet. Now, technically, it's over 1. Yeah, because 1 times 1 is 1. So that would be just 9 feet. Now, I know you could have done that 5 minutes ago while you're listening to me talk. 3 yards is definitely 9 feet. So once you get the result, hopefully intuitively it makes sense. But I'm still going to show you the procedure because not all of these problems are going to be so obvious. How about this one? Convert 5 yards. Sorry. Convert 72 inches to blank yards. Come on back to me. Come on back. Please come back. It never ends, does it? All right, well, while we're waiting for it to think, you can think about how this works. 72 inches into yards. If you already know the answer, you can just write it down, right? So, come on. I don't have time for this. Maybe that'll help. Come on back. Come on back. I don't know. It's driving me nuts. Come on. Come back to me. Come back to me. Please come back to me. Well, I don't know. So we've got 72 IN for inches. Multiply by a unit fraction. Hopefully this camera will come back. Come back. Come back to me. Don't leave me now. It's getting really blurry. I can't talk like this when it's this blurry. Come on. How about the calculator? You like the calculator? Come on. Focus on something. Focus on something. Come on. Really? There we go. God, don't do this to me. So, now, one of these ones that I didn't give you a direct translation from inches to yards. It's just not in the list. It's not one of the ones that we typically memorize. It's 36 if you want to memorize it, but so you already know the answer is going to be 2, right? But I'm going to show you the way to do it, all right? The way to do it is to find a unit proportion, all right? Put what you're trying to get rid of in the denominator. So you're trying to get rid of inches, all right? And then if you already know, you can make up a new one. I'm just going to use the one we already memorized. 1 foot is 12 inches. Got to be really careful where you put the 12. So 12 inches, denominator, 1 foot. Remember, my goal is yards. So my goal, I want to put that in the last one. My goal is yards, and I'm trying to get rid of the inches, and I'm trying to get rid of the feet. So 3 feet is 1 yard. Again, 1 yard is 3 feet. Okay? And then just for safety, you can just put an invisible 1 down here. It's mainly so that if you're a sloppy writer, some people are really sloppy and they'll write it like this. I've seen students accidentally go like this, and they'll go 72 times 12 times 3. So this is really just to prevent sloppiness. You just put an invisible 1 here, and then you just multiply straight across. You want to cross off all of the corresponding inches and feet, and you want to keep the final value as yards. So 72 times 1 times 1, that's 72. 72 yards, and then 1 times 12 times 3, that's 36. All right, and again, if you're really good at mental math, you already did this 5 minutes ago, and you know that it's 2 yards. The answer is 2 yards. Okay. Convert 15,000 feet into miles. $15,000 into miles. All right, so this is one you might not know. So feet and miles right here. Find the one that uses the values that are in the problem. So feet and miles, feet and miles. So 1 mile is 5,280 feet. So I've got 15,000 feet. The unit fraction is 5,280 feet is 1 mile, MI for mile. And then just for good measure, put the 1 down in the denominator. We cross off the feet, multiply straight across. You're going to get 15,000. Keep the unit that you're trying to get, miles for miles. Make sure you keep that. And then multiply the denominator, 1 times 5,280. And then for these big numbers, I'm going to use a calculator. And I'm going to get 2.840909 miles. Let's just round to 1 decimal place. So just like you would do on your car. If you look when you're driving, you look at the odometer, it only goes to tenths of a mile. So we'll just say 2.8. I'll use the squiggly approximately 2.8 miles. So 15,000 feet is approximately 2.8 miles. Okay. Some of the conversions are exact. They come out to be exact values, and some of them come out to be approximations. Just look for the little squiggly sign, or look for some indicator that you're going to be rounding your answer. If there is no indicator, then just enter whatever you get, and we'll see how it goes from there. I didn't make these too terribly difficult, so how about let's convert. I don't know. Let's convert 8 inches into centimeters. So 8 inches is how many centimeters? That's one that you typically don't memorize unless you grew up in another country that uses centimeters, or if you're an engineering science major and you've had a lot of experience with the metric system. I've been doing this for a long time, and occasionally I forget and I have to look it up on the internet. So that's the reason why I made this handout here, right? This is one you might not always know. 1 inch is 2.54 centimeters. That's probably how I keep screwing up the camera, by holding it up like that. So I've got 8 inches multiplied by a unit fraction. I'm trying to get rid of the inches, right? Centimeters is what my goal is, so that goes in the numerator. Look on your conversion sheet, 2.54 centimeters. So I need to give myself some more space. 2.54 centimeters is 1 inch. And again, just put a 1 down here for safe measure. Cross off the inches, multiply straight across. All right. If the denominator is just 1, you can just omit it. So 8 times 2.54, 8 times 2.54 is 20.32 centimeters. And this is actually an approximation. So it's approximately that, or you could round it to 1 decimal place. Again, if it accepts this answer, it will accept both of these answers, this type of problem. Probably wouldn't accept 20. 20 is not close enough, so 20, at least one decimal place. That's the standard if you don't see any specification, then just give me one decimal place. Some of them will very much specify. Okay. So the idea is you're always either multiplying, well, you're always multiplying straight across, and then sometimes you have a second step, which is to divide. If the denominator's 1, then you don't have that second step. It's done. If the denominator is something other than 1, then you need to divide. One thing that you might notice on your car, or if you're traveling, is miles and kilometers on your speedometer. It'll say, you're going, 70 miles an hour, but then that'll say 100 kilometers, 105 kilometers or something like that, right? So let's convert 96 kilometers, km, here I'll write the whole word out, kilometers, into miles. Right. This one's actually quite useful, right? If you ever get out of the house and get to travel eventually, you go to Canada or you go to Mexico or you go anywhere in the world essentially, and the street signs are not going to say miles, they're going to say kilometers. How many kilometers, km, right? Kilometers, 1,000 meters. And in your mind, you're thinking, well, I don't know how far 96 kilometers is, right? The kids are saying, how far until we get there? And just tell the kids, oh, it's 96 kilometers until we get there. They're not going to have any idea how long 96 kilometers is, right? Maybe you do. I honestly don't. I have to do the math to figure it out. So 96 km, that's kilometers. And then look on your sheet here. If you see the squiggle, it's like a squiggly equal sign. That means it's approximately. So 1 kilometer is approximately 0.62 miles. All right. So 1 kilometer is approximately 0.62 miles. Yeah. Or you actually have a choice. You might not want a choice, but I actually, with kilometers and miles, this one comes up so frequently that I gave you two choices. Or you can do 1.61 kilometers, that's the last one on the sheet here, is 1 mile. Right. Both of these calculations should give you approximately the same answer, the same result. So let's do it this way. We'll cross off the kilometers. I like this way because you just multiply. So you got 96 times 0.62, and that gives you 59.52 miles. Again, over 1, but we typically omit the 1. So I'll say 59.5 miles. We don't use M for miles because M is for meters, and so MI is for miles. Or, if you prefer to do it this way, I don't know why you would, but I give you the option. Cancel the kilometers, multiply straight across, and so you get 96 over 1.61. 96 divided by 1.61. It's 59.6 miles. So it's going to be close, but remember, these are approximations, so none of the conversions that have the approximately sign are going to give you exactly the same value. But these are pretty close. I would actually just say 60 miles. Yeah. Yeah, 96 kilometers is about 60 miles. Yeah. You probably noticed that on your car, right? If you're driving at 60 miles an hour, the kilometers are, right between 90 and 100. Most speedometers don't have 96 on it, but it'll have 90 and then it'll have 100, and so you're between 90 and 100. Okay, so that is distance. There are a few other ones I'll have you play with. Meters and feet. You can do that as well. Maybe I'll do one more, meters and feet, and then we'll move on to something else. Convert 12 feet into meters. And there it goes again, isn't it? Isn't that just great? So 12 feet is what I'm starting with. I want to get rid of the feet. I'm hoping it'll just come back to me. Come back to me. I don't know if you can see that. So what do we got? We got 1 meter is 3.28 feet. 3.28 feet is 1 m for meters. All right, that's right here. 1 meter is approximately 3.28 feet. So it's not quite exact, it's approximately. Cancel the feet, multiply straight across, and if the denominator is not 1, then divide it. So you got 12 divided by 3.28, which is approximately 3.658 meters, or let's just say 3.7 meters. All right, and there you have it. So those are the conversions of distance. Distance is finding, length. The next conversion that we'll talk about is volume. Volume is the amount of space in a container, right? It's kind of like size, how big is the box, or how big is the cup, or the container that you have it in. So this is some sort of mystery container, and then you have the different volumes. You might have memorized these. I don't know if anybody's really into cooking, or if you ever had a science class that had some cooking math inside of it, or chemistry where you have to know these different units. Some of them are easy to remember, like a gallon is 4 quarts. That's kind of easy to remember. Some of the other ones you might not have memorized. I don't know. So example 11. Convert 144 cups into gallons. So cups and gallons. So you got 144 C. We usually use C for cups. Okay. Now I already know I got to put C in the bottom. I mean, I would do that right away before you even look at the sheet. All right. Because one of the main problems that I get is confusion about who do I pick and how do I choose it, and it's easy to get hung up on the choice. So that is what you have to do even before you've even looked at the sheet. So now look at the sheet. Gallon. Gallon goes to quarts. Nope, there's no cups. Quart, pints. Nope, no cups. Go to the smallest one that you can find with a cup. So we got a pint. So 1 pint is 2 cups. That's a unit proportion. But now you have to get rid of pints. So put pints in the bottom now. And then look at the next one. 2 pints is 1 quart. QT for quart. Well, now you have to get rid of quarts. So put QT in the bottom. That's quarts. Quarts is like a quarter. Yeah, quart. A fourth. 4 quarts is 1 gallon. Now, if you do this all the time, you'll probably just memorize it's 16 cups. Right? 2 times 2 times 4 is 16. And then you can skip a lot of these steps. I didn't put that on here because I want you to go through step by step. So cancel the cups, cancel the pints, cancel the quarts, and your goal is always the last numerator unit. And then again, if you like to put a 1 on the bottom to make sure that everybody goes horizontally. Right? Notice I'm not cross multiplying. right? I am multiplying straight across, parallel multiplying. All right. The only crossing you're doing is crossing off the units, canceling, cross-canceling, but you're multiplying straight across. So 144 times 1 times 1 times 1, so the numerator is still 144. And the denominator, all the units are gone, so it's 1 times 2 times 2 times 4, that's 16. This one's not approximate, at least I don't think it is, comes out exact. 144 divided by 16 is exactly 9 gallons. All right. Now, you know, if you already knew that 16 cups is a gallon, then you would read the question, 16 cups is a gallon, divide by 16, boom, you get 9 gallons. The problem is most people don't walk around in their life or, you know, get up in the morning and remember that, right? You know, you can go on the internet and Google it, you know, how many gallons is 144 cups, but then you're not really learning. The Google is just telling you the answer. So, and this technique is going to be used in the next 2 or 3 classes that you go to, and it's also going to broaden out into your science classes and other areas that you might be interested in studying. So. The main confusion that people have is, do I divide or do I multiply? And I would just tell you not to worry about it. Just set up the proportions. Sometimes you'll multiply and sometimes you'll divide. I wouldn't try to memorize any kind of pattern. I would just take it, you know, each one as it comes. How about this? Convert pints to gallons. That one's a lot easier. We probably should have done that one first. 128 PT. All right. I know that 1 quart is 2 pints. And I know that 4 quarts is 1 gallon. Basically the same question we just did. So you're going to cross off the pints, cross off the quarts, multiply straight across, multiply across the bottom, and that will be your answer in gallons. Most of these non-metric system ones come out exactly. So 128 pints is 16 gallons. What other measurement do we have? Fluid ounces. Convert 512 fluid ounces, F-L-O-Z. You can't just say ounces. People often do, right? When they're, you know, measuring stuff, they'll just say 512 ounces, but this is fluid ounces, so it's measuring volume. It's, you know, how much space it actually takes up. It's not necessarily measuring the weight. The weight could vary, and we'll talk about weight next. Into cups. 512 fluid ounces into cups. So 512. All right. You know you want to get rid of, we call these flaws, F-L-O-Z, flaws. So you know you want to get rid of your flaws, fluid ounces. So I've got 8 fluid ounces is 1 cup. Or you can just put C for cup. Cancel the fluid ounces. Multiply straight across. Multiply straight across. And then, if necessary, divide. All right, this is the step where you know, is it necessary? If that's not 1, then you need to divide. 512 divided by 8 is 64 cups. And so we continue. Let's do one with the metric system. You know, in Mexico and in Canada, that's our two closest neighbors to the United States. If you're traveling, if you ever get a chance to go and visit, hopefully you all have at some point, when you go to buy gas, they sell gas by the liter. Yeah. And so you'll see the price. I remember the first time I ever went to Mexico and I pulled into the Pemex, and it said, 12 pesos. And I was like, wow, 12 pesos? That's like less than $1. Yeah. And then I realized, oh, wait a minute. It's less than $1 per liter, not per gallon. But so when you see the price, it might seem cheap, right? But it's you're paying per liter. By the time you multiply it all out, it's probably the same. So convert 25 liters into gallons. And that also happens. So you'll be sitting there filling your tank, and it'll say, "Oh, you put 25 liters into your tank." 25 liters. And if you're not familiar with the metric system, you're gonna be like, "I don't know how much 25 liters is." All right. So what is it? You know what gallons are, right? Gallon of milk, gallon of gas. Right? You deal with gallons all the time, right? But liters, not so much, right? So the symbol for liters is L. It's usually a capital L, but you can actually use any L you want. You have a metric system conversion here, which is, again, approximately. If you look these up on the internet, you'll see maybe varying versions of this. Depends on how many decimal points they want to give you. I just chose 2 decimal places. I figured that was enough. But it actually goes on and on and on and on and on. So 3.79 liters is 1 gallon. Yeah. So that converts the liters into gallons. So you're going to multiply. You're going to get 25 G or gal over, multiply the bottom, 3.79. Now the L's are gone. The L's have been crossed off. So make sure you don't do that. All right. That's a very common mistake. Just keep that L in there. That L is gone. It's been converted. That's the whole point. And so now you've got 25 divided by 3.79. And again, it's not exact. It's approximately 6.59 gallons. Or let's just do 1 decimal, 6.6. All right. So 25 liters is approximately 6.6 gallons. Okay, so that is volume. Volume is also known as capacity. Space, how much space is taken up by it. Right? It doesn't necessarily mean what it weighs, because you can have a gallon of milk and you can have a gallon of water and they don't weigh the same, right? Milk is a little heavier than water, yeah? And so it has a little bit to do with physics and the density, and I'm not going to give a whole lecture on physics today. But the next topic is, in fact, weight. So again, weight is just the force pushing down on the surface of the Earth. Now, I made the surface of the Earth look flat, but we all know it's not really flat. But to draw a nice picture of it, I just made it look flat. So weight is the amount of force pushing down on your body, or on whatever it is that you're weighing. You could weigh a brick of gold, and you could weigh a brick of, pudding. I don't know why I said that. A brick of pudding. Jello, let's say Jello. And they could be the same size. They could have the same volume, right? 2 equally sized, bricks. But one of them's made of Jello, and the other one's solid, and it's heavy, and it's dense, and it's gold, and they're obviously not going to weigh the same. They're going to push down at different rates. And here I go trying to give a physics lecture that I'm not going to give today. It's a little bit out of my ballpark. But I do want to teach you how to convert weight. Yeah. Now, when you say OZ, it's not FLOZ, it's just OZ, that's weight. That's actual ounces. All right. And let's convert that into pounds. LBS is libras? I always get that wrong. Pounds. I think it's Libra, right? Libra, like the scales. Anybody into astrology? We got any Libras out there? Okay. I guess Libra would be book, right? So don't go to the deli and ask for 5 Libros. They'll give you $5. You know, it's 5 pounds. All right, so 208 ounces into pounds. So 208 ounces. You know you're trying to get rid of the ounces. So whatever you're trying to get rid of, that goes on the denominator every time. You notice how each problem I'm using exactly the same technique, which really means I don't have to go on much longer because I hope you're getting the idea. All right, it doesn't really matter what the numbers are. All right, so do that first before you look. Now, if you already know 16 ounces to a pound, that's great. 16 ounces, 1 lb. Yeah, or you could say lbs, I guess. It looks silly, but I'm going to put it anyway. 1 pounds. Yeah. And so you get 1 pound is 16 ounces. That's one that a lot of folks memorize. Cross off the OZ. Multiply straight across. Oh, sorry. Multiply straight across. 208 lbs. Multiply straight across. 16. Remember, the bottom is unitless now. There's no more OZ. It's gone. And then divide that. 208 divided by 16, and you get exactly 13 pounds. $14 or $13? I don't know. $13? What's the next one I want to do? Oh, this is one you might not have heard of. Stone. Stone is an Old English unit of measure. And even though I'm calling it Old English, I have heard from an acquaintance that in England, on your driver's license, it actually tells how much you weigh in stone, which I actually like this because it makes it sound like you're a lot lighter. So it's 14 pounds is 1 stone. Yeah, it's on here. 1 stone is 14 pounds. Good, and that brought it back to me. So I've got 196 pounds. That's what I would weigh on my American driver's license, if I'm lucky. All right. And then put what you're trying to get rid of in the bottom. You're trying to get rid of pounds. So 14 pounds is 1 ST for stone. ST, stone. You could just put S, but a S is also used for other things. So ST for stone. Cross off the pounds. Multiply straight across. 196 over 14 stone. 196 divided by 14. Oh, I love that. 14 stone. 196 is 14 times 14. So when you divide it, it comes out to exactly 14 stone. So a DIY problem for all of you. You all have different weights, varying weights. Figure out just for fun how many stone you weigh. And then if you're weighing something very, very big, you would use tons. Tons, yeah, the size of a train or a car even can weigh, tons. Yeah, you see the truck commercials, 4 ton, 2 ton, whatever. All right. So a ton is 2,000 pounds. Yeah, easy to remember. 2,000. It's not a 1. That would be a 1,000. A ton, 2,000. So you have 9,000 pounds. 2,000 pounds is 1 ton. We just use a capital T for ton. Cross off the pounds. Multiply straight across. The bottom is now 2,000, so divide it. We already know what that is. It's 4.5, but 9,000 divided by 2,000 is 4.5. 4.5 T. 4.5 tons, 9,000 pounds. In the metric system, they measure weight with kilos, kilograms. Convert 10 kilograms, also known as kilos, into pounds. All right. So you read an article, or you're doing a science experiment, or you're watching the news or whatever, and they mention something about 10 kilos, right? Well, 10 kilos, that sounds like a lot, right? 10 kilos. Well, let's see, how much is it really? Right? In a unit that you actually understand, right? So 10 kilos, kg for kilograms. Again, first step is to put in the denominator what you're trying to get rid of. Kilograms. Look on your conversion sheet, unless you have it memorized. 1 kilogram is 2.2 pounds. So 1 kilogram is 2.2 pounds. And again, this is why I've been saying this, repetitively. If you put this upside down, it's going to be wrong. All right. And the most common mistake is looking at the sheet, taking the numbers, and then just putting them in the wrong position. And then you won't even realize that you got it wrong. All right. Kill the kilograms, multiply straight across. You're going to get 220. Sorry, not 220. 22 pounds. Again, over 1. So it's 22 pounds. I didn't even use the calculator on that one because you're multiplying by 10. Okay, so that's weight. And the last one, time. Time is interesting. Most of these you all know. I hope you know them. I think you all do. But time is based on sort of 3 different quantities. You have a year, right? A year is how long it takes for the Earth to go around the sun, right? I'm just saying this because you already know this. So the Earth goes around the sun once every 365 days. Now I'm ignoring leap year. And so you should do the same. We typically don't include leap year in this type of a math class. If we really wanted to get into the super scientific, detailed version of it, it's 365 and 1/4, 1/4 of a day. And that's the reason why every 4 years you have February 29th. We just, in this math class, we assume that February 29th doesn't exist. If any of you have a birthday on February 29th, you probably have gotten used to celebrating your birthday either on February 28th or March 1st most of the time, right? But then you have a day. A day is how long it takes the Earth to revolve around its own axis, right? And the axis is slightly tilted if you take an astronomy class, right? So that's 24 hours. But then an hour is 60 minutes, and so you have the clock, and then you have the minute hand, goes around 60 minutes, and then a minute is 60 seconds. I didn't draw the second hand on here. I just drew the hour and the minute hand. I guess you could put the second hand on there as well. Okay, so these are all well-known units. So I'm just going to end with the time, just in time. One of my longer lectures today. Let's go ahead and convert. 180 minutes into hours. That's an easy one. You can probably just do that in your head. It's 3, right? So by the way, I should just put this out there. If you read one of these questions and it's a well-known number that you've experienced in life, just do it, right? And then if you want to mimic the process so that you can do the more complicated ones, this is just for show here. I just want to show you. We have 60 minutes is 1 hour, and it's done, right? It's 180 divided by 60, and it's exactly as we expected, 3 hours, right? So guess or intuit, think what you think it's going to be, and then actually work it out and make sure you get what you get. All right. I can tell you from experience, I've been doing this for a long time, and sometimes when I think I know, and I'll be like so confident that I know, and then I'll actually do the math and I'll be like, oh no, it's not what I thought it was. Here's one that you might not know. Convert 1 year into minutes. How many minutes are in a year? Now, if you've seen the musical Rent, you already know the answer. You're probably hearing the song in your head right now. I know I am. But this is how they got that number, right? 1 year. All right, so I want to get rid of years. Put years in the bottom. All right, so let's go through this. 1 year is 365 days. We'll just put D for days. Okay. But then 1 day is 24 hours. The sun keeps going behind a cloud and making this spooky. And then 1 hour is 60 minutes. So you're going to cancel off the years, cancel off the days, cancel off the hours, and your goal is minutes. That's your goal. Yeah. And just multiply straight across. So it's 365 times 24 times 60 all over 1. And you don't need to put the 1 because it's divided by 1. 365 times 24 times 60 is 525,600 minutes. And there you have it. So now we usually omit the 1 here. Okay. I think I'll just do one more. I think you've had enough. The last example today is a little bit of an advertisement. I don't know if it's not a very good advertisement. I don't think I'm going to convince anybody that's not already interested. But have you ever, you do a math problem, and you'll probably do a lot of these next semester, where the answer is in feet per second. So it's again a rate, going back to what we were talking about earlier in chapter 6. So this is a rate of speed, 120 feet per second. And so, you know, this will happen. I know if you take my intermediate or beginning or advanced, whatever math class you take, when we do word problems involving motion and how fast a car is moving or how fast somebody is running or whatever it is, some object moving around, we usually give the answer in feet per second. It's just very common in the American system to do it that way. In the metric system, it would be meters per second. So if you're taking a physics class or an engineering class, it's often done in meters per second. But in the standard American system, we measure with feet and then seconds. But that's not the way we think, right? Most Americans think in terms of miles per hour because you get in your car and you drive and you look at the speedometer. And I know that everybody that's watching this video right now, if I say 60 miles an hour, you know what that is. All right? If I say 90 miles an hour, you know what that is. Not only do you mentally know what that is, but you intuitively know what 90 miles an hour feels like. Right? Something that it's been ingrained in you since you were sitting in the little car seat as a baby. Right? But if I were to ask my class, how fast is 120 feet per second? You don't know what that means. It sounds fast, right? It sounds really fast, 120 feet per second. It might very well be fast. I don't know. In order to really get a good idea of how fast something is, you convert it into miles per hour, right? And then you get a better idea of what it means. So 120, right? Feet. Now this is going to be a tricky one because watch, it's a rate. So the bottom is 1, but unlike all the other problems, this is a rate. So I have to also put the time. So this is a combination of distance and time. You combine distance and time as a fraction. Distance goes on top, that's the feet. Time goes on the bottom, and you put that together, and that's what we call a rate of speed. Yeah, back in the previous, or a unit rate of speed. So unit rate of speed. So I have to get rid of miles per hour really means miles over hours. Yeah, miles per hour, MPH. Yeah. So I've got to get rid of the feet and turn them into miles. And then I also have to get rid of the seconds. So watch how I get rid of the seconds. I put seconds in the top, in the numerator, to get rid of the seconds. 60 seconds is 1 minute. And then I also have to get rid of the minutes. 60 minutes is 1 hour. This is the type of thing that you really need the process for. I mean, I don't know anybody that would, I'm sure I've met somebody in my life, but most people, 99% of human beings, they can't just read 120 feet per second and go, oh, it's 7 miles an hour. Or 12 miles an hour, whatever they come up with. It's probably not right. You do it this way, you're going to get it right. So you're going to cancel off the feet. All right. My goal is miles. Check. I got my goal. All right. Cancel off the seconds. Cancel off the minutes. And you got your goal of hours. So that's your goal. Yeah. So don't kill your goal. Don't cancel out your goals. Right? Cancel out the intermediary factors and then keep the ones that you're trying to get. You're trying to get miles and hours. And then just multiply straight across. So you've got 120 times 1 times 60 times 60 over 1. You don't even have to put the ones. Times 5,280 times 1 times 1. And normally we just omit the ones. So what do we got? 120 times 60 times 60. 432,000. And again, this is a MPH, right? Miles per hour. And then the bottom is just 5,280. Yeah, 5,280 times 1 times 1 times 1, still 5,280. So divided by 5,280 is approximately 81.8 miles per hour. Just round to 1 decimal place if necessary. Sometimes it comes out exact. You don't need to round, as we talked about before. All right, so now you get an idea. That's pretty fast. I mean, that's like going really fast on the freeway. Yeah, so when you're going really fast on the freeway, 81 miles an hour, that means you are traveling 120 feet every second. which is the whole reason why we have the whole law about braking distance, right? Because a second goes by like that, or maybe like this, a second, and you've already traveled 120 feet. Right? I mean, if you're not paying attention, I don't know. I don't need to sit here and tell you how to drive. But I am going to sit here and tell you that we are done with this section. And so, congratulations. Made it through chapter 6. It's been a pleasure. I hope that we see each other again. But until then, this is Dr. Jordan. I'll see you on the internet.